All right, in section 7.3, you're going to learn about some special products. These products are a little different than normal polynomials. You can actually use some tools and some hints and some tricks to make it easier when you're multiplying polynomials together. So let's first start off with what are we going to learn. All right, in these special products, you're going to use the square of a binomial pattern, you're going to use the sum and the difference pattern, and you're going to use special product patterns to solve real-life problems. So, using the square of a binomial pattern, here's what it means. You're going to be given this, a binomial squared. That's it. Now, a big mistake people make, this is a huge mistake, like probably one of the biggest mistakes I see. People take the y plus 5 and they square it, and they get this. They square the y, they square the 5, and they get y squared plus 25. That is not right at all. Because when you have y plus 5 squared, that really means y plus 5 times y plus 5. And you're going to actually FOIL or distribute this to get y squared plus 10y plus 25 is your final answer. By just squaring each term, you're not actually doing the middle term, which you need to do. So here's your shortcut. Your shortcut is this. If you square a binomial, you take the first term and you square it, you take the last term and you square it. But then you multiply both of the a and b together and double it. And that gives you your middle term. And this proves why. You square the a, you square the b, and then you double a times b, because since we have two of them here. So here's your core concept. Watch what we do. A plus b squared gives you a squared, and then you double the a times b, and then plus b squared. If you did it here, it'd say this, x plus 5. So you square the x, you get x squared. You square the 5, you get 25. And then you multiply the two terms together, 5 times x, and you double it. That gives us 10x. Could you still multiply it by doing this? X plus 5 times x plus 5, and you just multiply each term in one parenthesis times each term in another? You absolutely can. But this is another tool that you can use to multiply this. The next one is exactly the same, except it's a minus b. So when you take a times the b and double it, it's just minus that. So here we would take 2x, we would square it. That gives me 4x squared. We take 3 squared to get 9. And then you take 3 times 2x, get 6x. Double it, gives us 12x. And it's minus 12x. So let's do example 1 together using this concept. In A, I have 3x plus 4 squared. So I'm going to take the 3x and I'm going to square it. That gives me 9x squared. I take the 4 and I square it. That gives me my last term, which is plus 16. I then multiply these together. So that gives me 12x, and I double it. Whoops, and doubling it would give us 24x. So my answer would be 9x squared plus 24x plus 16. Now in B, I do the same thing. 5x squared gives me 25x squared. 2y squared gives me plus 4y squared. Multiply them together. 5x times 2y, that's something new. You're going to get 10xy. Double it, I get 20xy. Now remember, since there's a minus, it's minus 20xy. And there's my answer. 25x squared minus 20xy plus 4y squared. Now, using the sum and difference pattern, this is my favorite because this one's so easy. When you find the product, before you look at anything else, If your binomials are exactly the same, except one's a plus and one's a minus, you can actually use this rule. Here's what it says. If I FOILed this, look what I did here. X times x is x squared. X times minus 2 or negative 2 is negative 2x, and then negative 4. What happens to your two middle terms? They cancel. Because they cancel, you're left with just the first term and the last term, x squared minus 4. This is where we get the next core concept. The next core concept says this. A plus b times a minus b. You just take a times a, get a squared. Minus, it's always minus. Always minus. And b times b is b squared. So if I had x plus 3 times x minus 3, it'd just be x squared minus 9. We do not have to worry about the inside terms because they're going to cancel. So example 2, using the sum and difference pattern. T squared minus 25. That's it. T times t is t squared. 5 times negative 5 is negative 25. Done. This one, 3 times 3x, we're going to square it, 9x squared. We square y times y, or just y times y is y squared, and it's minus. 9x squared minus y squared. But don't do this. I see this so many times as well. Oh, I can use it here. X squared minus 12. No. They have to be exactly the same except one's minus, one's plus. Because you have 3 and 4, your final answer here is going to be this. You are going to have a middle term. So make sure you do not do this if everything's not the same except the plus and the minus. Now this is something that I've never seen before. This is new to me. You can actually use those special product patterns to use mental math to find certain products of numbers. So let's just say you're going to multiply 26 times 34. Watch how this works. This is very interesting to me. I've never seen this. I could take 26 times 34. Well, you probably can't do that in your head, and that's okay. But 26 and 34 are close to 30. So how do you get 26? You get 30 minus 4. How do I get 34 from 30? I do 30 plus 4. Notice that both 26 and 34, they are both 4 away from 30. So I can rewrite it like this and do it completely in my head. 30 times 30 is 900. 4 times 4 is 16. 900 minus 16 gives me 884. So that is a method or a tool that you can use to multiply basic numbers that are the same distance away from something. And our last real life problem. This entire thing is one problem. It's going to take 2 or 3 slides. Example 4. A combination of 2 genes determines the color of the dark patches of a border collie's coat. An offspring inherits one patch color gene from each parent. Each parent has 2 color genes, and the offspring has an equal chance of inheriting either one. So this is actually called a Punnett square. The gene B, capital B, is for black patches, and the gene R is for red patches. This means, now the reason it's capital is because this is a dominant gene. Anything that stands for a B automatically is black. So any gene combination with the capital B results in black patches. Suppose each parent has the same gene combination, BR. That means you would take B times B, get BB, B times R, BR, B times R, BR, and R times R is RR. The Punnett square here shows all the combinations that the offspring may have with the resulting patch colors. So A, what percent of possible gene combinations result in black patches? Well, A is easy because there are 3 black patches out of a total of 4. So we know for A, 75% of the possible gene combinations result in black patches. But here comes part B. Part B says show how you can use a polynomial to model the possible gene combination. Now you're probably thinking to yourself, what? So here's how you're going to start it. Each parent has a B and an R, so it's a B plus an R trait. Each one has an equal chance of getting it. Equal chance means it's 50%, which I'm going to let be as a decimal. So each parent has half B, or 0.5 B plus 0.5 R. Since we multiply them together to get our Punnett square, we can square that expression, which would give us this. If I square this using our simplification, we get 0.25 B squared. Then we multiply them together, so 0.5 times 0.5 will give us 0.25, and we double it. So that would be 0.5 BR. And then we square the last one, which gives us 0.25 R squared. And this is what we then have to look at. This is what we have written down right here. 0.25, it represents percent. So 25% represent black patches. 50% BR, also black patches. And 25% is the remaining RR. So because the coefficients show that 25, right here, 25% plus 50%, that's how we get 75% is the possible gene combination result in black patches.